Hey everyone, in today's video we are going to be looking at significant figures and in particular how we can determine the amount of significant figures in a measurement. So starting us off, you might be asking yourself, what is a significant figure? Well, significant figures are used by scientists to show or represent how precise the lab equipment they've used in some sort of experiment is. Generally speaking, the more precise the piece of a lab equipment, the more valid the data is going to be. When we're thinking of lab equipment, we're thinking about things we might encounter in a chemistry lab, like rulers or balances or beakers or graduated cylinders. All of those pieces of equipment are used to make measurements, and each one has a unique amount of significant figures associated with it. So you guys have probably been making measurements in your science classes for a couple of years now, but you may not have ever been taught how to take a proper measurement using significant figures, and that's what this video is going to focus on. So the first thing to recognize is that when we're looking at a piece of equipment, and in this case we're going to be going ahead and looking at this blue ruler here, and this blue ruler is measuring the black line that's right above the blue ruler. The first question you want to ask yourself when looking at any type of lab equipment is, what are the increments on that piece of a lab equipment? Or what does that piece of equipment count by? So when we take a look at this ruler, I can see the number 1, I can see the number 2, and I can see that in between 1 and 2, there are all of these small dashed lines, all of these graduations. Well, this ruler is broken up to count by 0.1, or counting by the 10th place. So when I look at the measurement for the black line, I can be certain that I have at least 2.1 centimeters of the black line, that the black line is at least 2.1 centimeters long. What I'm not certain of is the space in between those graduations. So this black line falls a little bit above 2.1 and a little bit below 2.2. So for every measurement, we want to record what we are certain about. So I'm certain that I have 2.1, but we also want to include an estimated digit. So we want to estimate one beyond what we can see. So I can see to the 10th place, I need to estimate one digit or one place value beyond what I can see. So for this measurement, I estimated that that is 0.05, so it would be 2.15 overall. The cool thing about an estimated digit is that they cannot be right or wrong. So if you were to take a measurement here and you estimated that it was 2.13 or 2.14, both of those would also be correct because the estimated digit cannot be wrong. Now that we've had an opportunity to look at how to make a measurement using the proper number of sig figs, let's go ahead and look at how can we figure out the amount of significant figures if we're given a measurement. So in order to help us do this, there are a couple of rules that we have to follow. The first rule is probably the most basic. Non-zero integers are always considered significant. So if I'm given a number and I'm asked how many significant figures are in that number, and it has any number between 1 and 9, those numbers are always going to be counted as a significant figure. Where it gets a little more tricky is when we look at numbers that have zeros in them. So the next 3 rules that we're going to look at are all related to zeros, and there are 3 different types of zeros that exist. The first type of zero that we're going to look at is a leading zero. So leading zeros are zeros that are going to come before your first non-zero number. Most of the time you're going to see these in a decimal, where those zeros are coming before your first non-zero number. And the thing to recognize is that these types of zeros are never considered significant. So here we have an example of 0.00045. All of those zeros at the front of the number are not significant, so we can cross them out, and we would actually say that this value only has 2 significant figures. The next type of zero is what we call a trailing zero. So trailing zeros are found at the end of a number. These zeros are a little bit more complicated because there are some exceptions here. Typically speaking, a zero that comes at the end of the number is not significant unless there is a decimal. So that's going to be the question you ask yourself if you see a 0 at the end of the number. Is there a decimal in the number? If there is, then any 0 in that number becomes significant. If there is not a decimal, then that trailing 0 is not significant. So if we look at our example here of 610 and 3.0, 610, the first question I'd ask myself is there a decimal? The answer is no. So this value would only have 2 significant figures. When I look at the next number, 3.0, I ask myself, is there a decimal? The answer is yes. So that 0 does become significant. So this value would also have 2 significant figures. The last type of 0 that we're going to be talking about is a captive 0. So captive zeros are zeros that are in between 2 non-zero integers. These types of zeros are always significant. So they're going to be the ones that are captured between 2 other numbers, like we see here in 702. Because that 0 is stuck between the 7 and the 2, it becomes a significant figure, and this would have a total of 3 significant figures. So now taking a look at our practice problems, in this first number we're looking at 1,234 and trying to figure out how many significant figures are in that number. The correct answer would be 4 significant figures from Rule 1 on the last slide. All 4 of those numbers are non-zero integers, which means they are always significant. In this next example problem, we're trying to figure out how many sig figs are in 0.0843. The thing to recognize is that at the beginning of this number, we have 2 leading zeros. And remember, leading zeros are never significant, so we can go ahead and cross those out, which leaves us with 3 non-zero integers. So this value overall would have 3 significant figures. In our next practice problem here, we're looking at how many significant figures are in 1,000. In order to solve this problem, we need to recognize that there are 3 trailing zeros in this value. So whenever we see trailing zeros, remember that question you want to ask yourself is there a decimal or not? So in this number, we do not see a decimal, which means that those trailing zeros are not significant. So this value would only have 1 significant figure. And here in our last practice problem, we're asking how many sig figs are in the number 10.0. So again, we need to recognize that we've got some trailing zeros in this number, and the question we need to ask ourselves is there a decimal? Which the answer in this situation is yes. Remember, if there's a decimal and trailing zeros, those trailing zeros do become significant. So overall, this value would have 3 significant figures. Now that we've had the opportunity to identify how many significant figures are in a measurement, we're going to go back and practice making measurements one more time. So remember, the first question you want to ask yourself when looking at whatever measuring device you're looking at, in this case a ruler, is what are the increments of the measuring device? Another way of saying that is what does the device or piece of lab equipment count by? What does the device count by? So when we take a look at this ruler, we see that there are smaller graduations in between the 11 and 12 and smaller graduations between each of these whole numbers, which means that this ruler is going to count by 0.1 or count by the tenths place. Now that we know what the ruler counts by, let's go ahead and practice making a measurement. So for this practice problem, we are looking at making a measurement at point B here. So remember, in your measurement, you want to include what you are certain of, as well as 1 estimated digit. So when I look at this value, I'm certain that I have 12.2. These are my certain values. I can see that B is at least 12.2. We also want to include 1 estimated digit. Remember, you want to make a measurement one place value beyond what you can see. So that B is falling in between 12.2 and 12.3. So I'm going to go ahead and estimate this as 12.24 centimeters. Make sure you're including your units in any measurement you're taking as well. The other thing to remember is that your estimated digit cannot be wrong. So if you had put 12.25 or maybe 12.23 centimeters, those would also be appropriate measurements. All right, taking a look, we're going to make one last measurement in this video. So here we're taking a measurement at point D. Remember, in your measurement, you want to include all of the values you're certain of plus one estimated digit. So when I take a look at this ruler, I am certain that I have 13.5 centimeters, but I still need to include my estimated digit. So I'm going to go ahead and estimate that digit as a 0. Because to me, that arrow looks like it's pointing pretty spot on to the 13.5. You could have made your estimated digit a 1, or maybe even made the recording as 13.49 versus 13.50. Any of those things would have been appropriate measurements. The thing to remember is that this ruler is the exact same ruler as what we were looking at on the past 2 slides, and the precision of a piece of equipment has to remain the same throughout the whole piece of equipment. It can't have different precisions at different points on the ruler. And that is it for our video.